give an example of a natural number, a whole number, an integer, a rational number, and a real number. 3 is a natural number. 7 is a whole number, because I just wanted an example. So you could have picked any number. You could have said 5, 50, a million. In fact, natural numbers are sometimes called whole numbers, so they're the same thing. Also, some people say that they begin with 0, while others say they begin with 1. So if you had to give one in an exam, both would be given as correct. 3 is an integer, but integers can be positive or negative. So you could also say -2. So the question was, give an example of. So if I say give an example of an integer, or you could just say any integer. So it could be -150 or plus 2,065,000. 2/7 is a rational example, or is an example of a rational number. It's basically a fraction. So a pair of numbers, a pair of integers, one divided by another. 3.141 is an example of a real number. So a number with decimal points. In general, real numbers also contain irrational numbers. So you could give an example. So you could say the square root of 3, which is called irrational because you can't write it as a fraction. But we just wanted an example of a real number, so I just picked 3.141. You had countless answers that you could have given. Evaluate the expressions below. So, adding fractions. So 1/5 plus 2/3, well, you just want to, you're trying to add apples and oranges, so you try and get them in the same form. So since we have 1/5 and 2/3, if we write them both as 15ths, then we can easily add them. So then 1/5 becomes 3/5, just multiply top and bottom by 3, and 2/3 becomes 10/15ths, multiplying top and bottom by 5. So once you have them both as 15ths, then it's easy to see what to do. So 3/15ths plus 10/15ths becomes 13/15ths. And remember, this actually took mankind 1,000 years before they were keeping records as, so many fifths and so many thirds, but they didn't know how to combine them. We had an example which is not actually adding fractions, it's multiplying. The thing is, even though there's nothing difficult in multiplying fractions, you just multiply the two things on top and the two things below, people tend to get confused and they do all kinds of crazy things thinking that it must be harder than it actually is, and end up with the wrong answer. So I just wanted to put in an example of multiplying to just remind you that it's actually very easy. So 2/5 times 5/7, well, you multiply the two numbers on top, so 2 times 5 is 10, and 5 times 7 is 35. So you end up with 10/35, and you could simplify by dividing top and bottom by 5 to get 2 7s. I mean, they're the same thing. Which of the following are prime numbers? Well, I just say 2, 7, 11 and 19 are, because I could factorize the other ones. So 4 is 2 times 2, so it can't be a prime. 15 is 3 times 5, again, not a prime. 21 is 7 times 3, and 99 is 11 times 9. Then break the following into prime factors. So any integer can be broken into its unique factors. So 52, well, I can see that's divisible by 2, so that's 2 times 26. Well, 26 can be broken down further, so it's 2 times 2 times 13. 26, again, I can divide it by 2, so I end up with 2 times 34. I can divide 34 by 2, so I end up with 2 times 2 times 17. Nearly there. So 152 is 2 times 76, which is 2 times 2 times 38, which is 2 times 2 times 2 times 19. So I end up with 19. That can't be broken down any further. And finally, 24 is 2 times 12. Well, 12 can be broken down into 2 times 6, and 6 can be broken into 2 times 3. So I end up with 2 times 2 times 2 times 3. And you could also write that as 2 to the power of 3 times 3. And finally, we have BODMAS. So just the order of manipulations. So 5 plus 3 times 2, well, you do the multiplication first, so you end up with 5 plus 6, and now you just add those, so that's equal to 11. Well, 5 plus 3 times 2, well, you do the bracket first, so you do 5 plus 3 first, so you end up with 8 times 2, and that's equal to 16. 3 plus 2 to the power of 2 multiplied by 2. Well, I want to look at what's in the bracket first, and then I do O, so I do the order next, like next priority, so I end up with 3 plus 4 inside the bracket. Now I add 3 plus 4 to get 7 times 2 is equal to 14. And remember, you can put these expressions into Google and it actually works it out correctly if you just want to practice and see, you know, if you're not sure what you're supposed to do. 4 minus 3 plus 2 times 3. Well, multiplication occurs first. So you do 4 minus 3 plus 6. And now you just do it from left to right. So 4 minus 3 is 1, plus 6 is 7. So that's the solutions to problem set 1. Remember to subscribe to be updated when the later problem sets are given.